Welcome back to Think Cosmos, where we ponder the universe's deepest secrets and wonders. For decades, the idea of extracting valuable resources from asteroids has lived in the realm of science fiction, a dream, a distant possibility. But in 2024, that changed. California-based startup AstroForge launched a groundbreaking deep space mission, Brocker 2, with one goal: visit and analyze a metal-rich asteroid for the very first time as a private company. If successful, this mission could mark the birth of an entirely new industry, one that reshapes how we explore space, build infrastructure off-world, and source resources, not from Earth, but from the billions of rocks orbiting beyond it. The space gold rush has officially begun. Brocker 2, the first private deep space prospector. AstroForge's Brocker 2 mission is small, nimble, and historic. It launched in early 2024. The spacecraft is on a trajectory to intercept a near-Earth asteroid, likely an M-type, a class of asteroid thought to contain abundant metals, including platinum group elements, nickel, etc., cobalt, and potentially rare earth minerals. The spacecraft is equipped with spectrometers to analyze surface composition, high-resolution cameras, and tech experiments designed to simulate future in-situ resource extraction. Brocker 2 follows Brocker 1, AstroForge's 2023 test mission, which demonstrated asteroid ore processing in low Earth orbit, vaporizing simulated asteroid rock to refine metals from regolith. Now, they're applying it in deep space. No other private company has ever attempted this. And if it works, AstroForge will be the first non-government actor to visit and evaluate a mining candidate beyond Earth orbit. Why asteroids? The case for space mining. Asteroids may look like rubble, but they're literal treasure chests. M-type asteroids can contain trillions of dollars in metals. Some estimates suggest a single kilometer-wide body could hold more platinum and gold than has ever been mined on Earth. But the case isn't just about wealth. It's about utility, metals for space construction, water ice that can be split into hydrogen and oxygen for fuel, silicated iron for on-site manufacturing. By sourcing materials in space, we eliminate the need to launch everything from Earth, saving enormous costs, reducing launch frequency, and enabling moon bases, Mars colonies, orbital shipyards, and interplanetary logistics hubs. It's the keystone of a self-sustaining space economy. Earth-based catalysts. The Bennu sample return. In late 2023, NASA's OSIRIS-REx returned to Earth, bringing back samples from the asteroid Bennu. Over 120 grams of pristine, 4.5 billion-year-old material. The samples confirmed that asteroid material can be collected safely, returned through Earth's atmosphere, and preserved for analysis. OSIRIS-REx didn't mine Bennu, but it proved the concept and gave us the scientific template for understanding surface cohesion, mineralogy, thermal behavior, microparticle densities. AstroForge and others are building directly on this knowledge. Who's next? The rise of the prospectors. AstroForge isn't alone. Across the world, public and private teams are racing to develop space resource extraction tools. NASA is investing in Atlantic ovens to extract water from lunar soil. ISRO, in situ resource utilization. Test beds, upcoming Viper rover to map water ice near the moon's south pole. China is developing robotic drills and sample return missions from near-Earth asteroids and lunar polar regions. Luxembourg and Japan are funding asteroid mining startups, including iSpace, which has already launched landers and is designing prospecting platforms. Startups like Transastra and Karman are building harvester spacecraft that use optical mining, vaporizing asteroid surfaces, using sunlight to extract materials without contact. Within a decade, we may see automated mining platforms, fuel depots, and raw material processors orbiting Earth, the Moon, and even Mars. The economics, from fiction to feasibility. Asteroid mining could reshape both space exploration and global industry. Some key projections: water mined in space could sell for $500 KU, still cheaper than launching from Earth. Rare metals could flood supply chains for green tech, batteries, and electronics. In-space manufacturing could reduce costs by orders of magnitude, enabling structures too large or fragile to survive launch. Space resources also allow for redundant fuel depots, emergency life support reserves, and supply chain independence from Earth. SpaceX, Blue Origin, and future lunar players may eventually rely on mined resources to build in orbit, not shipped from Cape Canaveral. Strategic stakes, policy, power, and the Space Resource Treaty. The shift toward resource extraction in space has also triggered geopolitical and legal debate. Under the Outer Space Treaty, 1967, no nation can claim sovereignty over a celestial body, but resource ownership remains murky. In 2015, the U.S. passed the Commercial Space Launch Competitiveness Act, granting American companies the right to extract and sell resources from space. Luxembourg and the UAE followed suit. China and Russia have their own frameworks, and the Artemis Accords, spearheaded by NASA, aim to set peaceful norms for lunar and asteroid resource rights. But what happens when multiple actors target the same body? Or when a valuable asteroid is claimed? The first successful missions will force the world to define the rules of space commerce before competition turns into conflict. Final thoughts. The first pickaxes on the frontier. In 1849, gold was discovered in California, and a new era began. In 2024, Brocker 2 launched to intercept a metal-rich asteroid, and perhaps the same thing is happening again. Only this time, the mines aren't on Earth. They're in the void. This first generation of asteroid miners will teach us what works, what's viable, and how far we can go. Because in the future, our civilization may not be built on Earth's crust, but on asteroidal veins of iron, platinum, and frozen water, waiting to be unlocked by the next explorer or algorithm.